the beginning of the semester when we had fractions in an equation. Okay? So think about this equation right here. This is a different problem. If I had 1/2 x plus 2/3 x equals 1/6, how would I solve that? It's one of the things that we did in that first chapter. What would I do to solve this? Okay? Change everything to the LCD. What is the LCD of 2, 3, and 6? 6. So what students want to do is they want to rewrite this with 6 as your common denominator. Okay? That was what students want to do. And then combine like terms and solve. But that's not what we need to do. That is an okay way to solve it, but it is more complex. It is more complex. What we do instead is we multiply everything by the LCD. That's how we do that. We multiply everything by the LCD. So we are going to use that principle with my above problem. Okay? We're going to use that same principle with this problem right here. So I am going to identify my LCD. The best way to do that is to look at the 3, the 4, and the 6. What number does 3, 4, and 6 go into evenly? 12. So my LCD is 12. So what I'm going to do is I am going to multiply all of this by 12 over 1. Okay? You don't need to get you're not going to keep each rational expression as a rational expression. We are going to multiply the whole thing by 12. We are able to do this because the directions say solve, and because there is an equal sign in the problem. That's why we are able to do this, because of those two things. So now I am going to multiply 12 over 1 times x minus 2 over 3. Then I've got 12 over 1 times x plus 1 over 4. Bless you. Okay? And then I've got 12 over 1. Okay? So I have multiplied 12 over 1 by each one of, so here is one of my rationals that I started with. There's my 12 over 1. Here's my second rational. I've multiplied it by 12 over 1. Here's my third, and I've multiplied it by 12 over 1. Now I cancel things out. So how many times does 3 go into 3? 1 time. So my 3 becomes a 1. How many times does 3 go into 12? 4. So now I have 4 times x minus 2. Now, is that easier to deal with? Yes, because we've eliminated that denominator. What number goes into both 12 and 4? What number goes into both 12 and 4? 4. How many times does 4 go into 4? How many times does 4 go into 12? Good. Okay, so then I'm left with 3 times x plus 1. Okay? What goes into both 6 and 12? 6. Good. 6 goes into 6 one time. 6 goes into 12 twice. So now I'm left with 2. Do you know how to solve this? Do you know how to solve this? Yes. We distribute and we solve for x. I'm going to give you 1 minute to do that. 1 minute to do that. Okay, what did you do first? Good, excellent. 4 times x is 4x. 4 times negative 2 is negative 8. Okay, then we distribute again. 3 times x, 3 times 1. Okay, does somebody have their music on by chance? If we can turn that down, that would be great. Okay, and then we are left with 2. We are going to combine like terms. I have 4x and 3x, so I have 7x. And then I have negative 8 and positive 3. What's negative 8 and positive 3? Good. I told my last class I was going to take a class in writing smaller so that we could get everything on one board. Okay, what's my next step?
Moving the 5 over.
Good. So I'm moving the 5 over. Going right here. So I have 7x equals 7. I divide both sides by 7, and what do you get?
1.
Good. Okay, now, in this particular case right here, we do not have a variable in the denominator. Okay? There's no 3x or x plus 4 or anything like that. What we're going to have to do next, the very next thing that we're going to start looking at, is does my answer make my problem undefined? So you want to get in the habit of taking this answer and asking yourself, will it make any of my denominators undefined? Now, we don't have a variable in any of these denominators, so we're okay. That means that this x equals 1 is fine. But I like to go ahead and mention it now because our very next problem, guess what it has in the denominator? A variable. Okay? So for this one, we are going to have to make sure that our answer does not make the problem undefined. Okay? So the first thing that I want us to do, we're going to use those same principles in order to solve this. We have to determine what is our LCD. Now our LCDs are more than just numbers right now. So we are going to look at this rational, and my denominator is n. So I'm going to write an n down under my LCD because I have to include that n. Then I move to my next rational. What's my denominator in my second rational? 2. Is 2 already accounted for in my LCD? No, so I have to write that down. Okay? Then I move to my third rational. What's the denominator? N. Is n already accounted for in my LCD? Yes, it is, so I don't have to write it down again. So my LCD is going to be 2n. 2n is my LCD. So what we're going to do is we're going to multiply this entire rational by 2n. Okay? So I'm going to say 2n over 1 times 5n. Then I'm going to say 2n over 1 times 1/2. And that equals 9 over n. And I've got to multiply that times 2n over 1. So again, I have taken each part of that equation. Each individual rational has been multiplied by my LCD. Now I cancel out my common stuff. So I've got an n here and I've got an n here. So then I'm left with 2 times 5. What's 2 times 5? Good. Okay. Here I've got a 2 and a 2. So I'm left with n times 1. Okay. Do I have to put the 1 in front of that? I don't have to. I can, but I don't have to. Okay. Then I have n and n. Okay, those cancel. What's 9 times 2?
18.
Good. And I'm thinking we probably don't need 60 seconds to solve this. What do I do? What do I do to solve this?
Move the 10 over.
Move the 10 over. So I'm going to subtract 10 from both sides. And I got n equals 8. Okay, now I have to ask myself the question. Does n equals 8 make this problem undefined? And what I mean by undefined is, does n equal 8 make a 0 in the denominator? That's what I am trying to avoid, because if I have a 0 in the denominator, my problem is undefined. So if I plug 8 in for n, in any of those denominators, will I get 0? I won't. Okay? So that is a step that you have to take. You have to go back and look to see and make sure that you aren't getting 0 in your denominator. What value is it that n could never be? What value could I never plug in for n in this situation? 0. Okay? Because if I plugged 0 in, that would make it undefined and it would be a problem. So you have to be aware of that. You have to always go back and look at that. Okay? So let's do our next one. Can I move off the screen? Okay. So let's do our next one. So I want us to look at these denominators. I've got a minus 2 here and I've got a plus 1. Okay? A minus 2 and a plus 1. Those are binomials. I have to keep the a minus 2 together, and I have to keep the a plus 1 together. What I want you to tell me is, what can a not be? A cannot be what? So look at this a minus 2. What would I plug in for a and get 0 in a minus 2? 2. So a cannot be 2. So if I got a 2 for my answer, I would have to throw it out, because 2 minus 2 gives me 0. And if you've ever looked at a calculator and you've tried to divide by 0, or you've ever asked Siri what 4 divided by 0 is, it'll be undefined. And I think Siri talks about the Cookie Monster. It's kind of funny. Okay? Now look at a plus 1. What is it that a can't be for that denominator? You got it, -1. Okay, now you don't have to do that for every single problem, but you do have to go back and think about it. Okay? You do have to look at your answer and look at those denominators. Now, you can look at the LCD. That would be a reasonable thing to look at. So in this situation, I'm going to write down my first denominator, which is a minus 2. Then I'm going to look at my second denominator. I've got a plus 1. Is that already accounted for in a minus 2? It's not. So I have to write down a plus 1. Now, if you're looking at this and you're saying, Alicia, can't I cross multiply there? The answer to that question is yes, you can cross multiply there. So if you used cross multiplication, you would be 100% correct, and it's completely acceptable to use cross multiplication here. Okay, I am not going to use cross multiplication here because in a minute we're going to do something with more. Instead of just having 2 rationals, we're going to have 3. And I want us to practice using the least common denominator. But I want you to also know that if you decided to cross multiply here, that is an acceptable way to do it. Okay? So, what I'm going to do is I am going to take my least common denominator, and I am going to multiply all of this times a minus 2 times a plus 1 over 1. So I have a minus 2 times a plus 1 over 1, and that is being multiplied by 3 over a minus 2. Okay? And then I've got a minus 2 times a plus 1 over 1. So I am multiplying everything by my LCD. Okay. So in my first one, I can cancel out a minus 2 and a minus 2. Excuse me. So I am left with 3 times a plus 1. Okay? Here, I've got a plus 1 and a plus 1 that I'm canceling out. And I am left with 4 times a minus 2. What do I do in order to solve this? Distribute. Okay? Take 60 seconds to solve that. Okay, we distribute. 3a plus 3 equals 4a minus 8. Okay? I'm going to subtract 4a from both sides. You might have chosen to subtract 3a from both sides, and that's fine. Either way is fine, but I'm going to subtract 4a. So I'm left with negative 1a plus 3 equals negative 8. My next step is subtract 3 from both sides. I'm left with negative 1a equals negative 11. What do I divide both sides by? Negative 1. Okay, so what is a? Good. A is positive 11. Now, if I plug 11 back into those denominators, that's all we're worried about are the denominators. Do I get 0 in either one of them? I don't. 11 minus 2 is 9. 11 plus 1 is 12. So I'm good. I don't have to do anything else. A equals 11 is an acceptable solution. Okay? Now, let's move on to the next one. Okay. I have A over A minus 2 plus 2/3 equals 2 over A minus 2. When you are looking at this, what is it that A cannot be for this one? Correct. A cannot be 2. So if I get 2 as an answer, what do I have to do? I have to throw it out. Okay, because 2 minus 2 gives me 0. It's not allowed. Okay? So I'm going to solve this. I am going to identify my LCD. Okay, what's my denominator here? Good, A minus 2. Okay, so I'm going to write that down. What's my denominator here? Do I already have a 3 in my LCD? No. So I've got to write down times 3. Okay, what's my denominator here? A minus 2. Is it already accounted for? Yes. So I don't have to write it down again. So I am going to multiply all of this by my LCD, which is 3 times A minus 2. I'm going to put over 1. That's what we're doing. 3 times A minus 2 over 1. Okay, so I have 3A minus 2 over 1 times A over A minus 2. Okay, then I have 3A minus 2 over 1 times 2 over 3. Okay, so I have multiplied my LCD times each one of those things. My LCD is 3 times A minus 2. Now I can eliminate those denominators, which is my goal, eliminating the denominators. So A minus 2 and A minus 2 cancel. What am I left with in my first rational? 3A. Excellent. You guys did great. Okay, for this one, I cancel the 3's. What am I left with?
Should be 2.
The 2 and what else? Excellent, excellent, excellent. So I have plus 2 times A minus 2. Okay? Then the next one. I cancel my A minus 2. What am I left with? 3 and 2, which is good. 3 times 2 is 6. Okay, can you solve this?
Yes, you can.
Good, go for it. I want you to solve it. You got 60 seconds. Okay, what do I have to do first here? What do I do first? Excellent, I distribute. So I've got 3A plus 2A minus 4 equals 6. 3A plus 2A is 5A. Okay, now I add 4 to both sides. So I have 5A equals 10. I divide by 5. What's A? 2. What did we say about 2? We can't have it. It's super, super important that you go back and look. Okay? You've got to go back and look right here. This is what you're looking at. If I plug 2 in to any of these, will I get a 0 anywhere? And I will. In A minus 2, if I plug a 2 in, I'm going to get a 0. That makes the whole thing undefined. So I have to throw this out. There is no solution to this problem. There is no solution. So my answer to this can be a couple of different things. It can be x equals 0 with a line through it. If you don't put that line through it, it means something different. So this right here means no solution. You can write the words no solution, or you can write the word undefined. Any of those are acceptable. The only thing that's not acceptable is x equals 2. X equals 2 is undefined, so we have to throw that out. Okay? Can I go to the next screen? Okay. This gets a little bit more complex. This one's getting a little bit more complex. I have x over 2x minus 8 plus 16 over x squared minus 16 equals 1/2. Okay. What do you think I need to do first before I can really determine my LCD?
I'm sensing that you need to factor the denominators.
Yes. So we want to factor those denominators. Okay? That's what we're going to do right now. So I want you to take 60 seconds and I want you to factor those two denominators. I want you to factor for me. Okay, what's my GCF in 2x minus 8? What's my GCF?
2.
2. So I got to pull out that 2. So I have 2 times x minus 4. That's my GCF. What does x squared minus 16 factor to?
That is
x minus 4x plus 4.
Good. Good. Okay, can I break 2 down any?
No.
No. So when you end up with something like this, you're always going to want to factor first. You're going to want to factor first. Okay? So once we have factored, then we are able to determine our undefined value. So sometimes it's easier to do your LCD first. So let's do our LCD first. So what is in this denominator right here? What do I have to write down for my LCD? 2 and x minus 4 have to be part of my LCD. Now I'm going to look at this one. X minus 4 is already included. So do I have to write it down again? No. What about x plus 4? Is it already included? No, so I have to write it down. Okay, now I'm going to look at my third one. There's a 2 there. Is it already included? So I don't need to write it down again. Once I have my LCD, then that's usually a good time to look at undefined values. If any one of those factors becomes 0, it's going to make the whole thing 0. So what is it that x cannot be for my LCD? X can't be what? It can't be 4, because if I plug 4 into x minus 4, I'll get 0. That makes it undefined. And x cannot be negative 4. That's what x cannot be. So what I'm going to do now, and this is where I need to write small. I am going to multiply all of this times my LCD. And my LCD is 2 times x minus 4 x plus 4. That's what I'm multiplying each individual thing by. And we're going to put that over 1. And I shouldn't say thing. That's what we're multiplying each individual rational by. So I have 2 times x minus 4 times x plus 4 over 1. And then I've got x over 2x minus 4. So the blue is staying the same. Then I've got 2 times x minus 4 times x plus 4 over 1 times 16 over x minus 4 x plus 4. And that equals 1/2. I've got to erase those. Let me write them somewhere else. So x can't be 4 and x can't be negative 4. Okay. And then I am multiplying 1/2 times 2 times x minus 4 times x plus 4 over 1. Now we're going to cancel some stuff out. X minus 4 and x minus 4. 2 and 2. What am I left with? X times, excellent, x times x plus 4. Okay? Then I've got x minus 4 and x minus 4, x plus 4 and x plus 4. What am I left with here? 2 times, excellent, 2 times 16. Okay, and then our next one, my 2 cancels. So I'm left with x minus 4 times x plus 4. What do I have to do in order to solve this? What's the first thing I'm going to do? Distribute, and then what am I going to do on the right-hand side?
That looks like a foil.
It is a FOIL, okay? I'm going to give you 1 minute to do that. 1 minute. Okay, x times x is x squared. X times 4 is 4x. 2 times 16 is 32. X minus 4 times x plus 4. When I FOIL that, I get x squared minus 16. Because what happens to the minus 4x and the plus 4x?
Cancel out.
Yes, it's difference of perfect squares. What's my next step here? What do I do next?
I'm seeing a trinomial that looks like it can be factored on the left side.
Okay, but before I can do that, before I can factor this trinomial, I've got to set it equal to 0. So I've got to get those x squareds on the same side. So I am going to subtract x squared from both sides, and when I do that, what happens? What happens to those x squared? They're gone. Okay? So now I'm left with 4x plus 32 equals negative 16. What's my next step here?
Add 16.
I don't need to set it equal to 0 because it's linear. I got rid of my x squareds. So now I'm just solving a linear equation. So I've got 4x plus 32 equals negative 16. So I'm not going to add 16 to both sides. What am I going to do?
Subtract 32.
Subtract 32. Good. If it was a quadratic, that's exactly what you would do. So here I've got 4x plus 32 equals negative 16.
You do 4x equals negative 48.
Good. Okay, and then we're going to divide by 4. So what is my answer here?
Negative 12.
Good. X equals negative 12. Okay. Is that okay? Does that make anything undefined? Here's my undefined values. Is x equals negative 12 okay?
That works.
It works. Okay? Okay, can I move to the next screen? Good. Okay, here we go. I have 2. Actually, it's just 2 over 1. Plus 4 over x minus 2 equals 8 over x squared minus 2x. I want to factor first. And just for the sake of time, I'm going to go ahead and factor. Okay? Just for the sake of time. So I'm going to go ahead and make my 2 over 1, just so I'm thinking about it in rational format or fraction format. Then, can x minus 2 be factored?
No.
No.
But the x squared minus 2x can.
You're correct.
You take out an x from that.
Good. Your GCF is x, so you can take it out. So my LCD is going to have a 1 in it. Do I have to write that 1 down?
No.
I don't have to. I certainly can, but I don't have to. Okay? Here I've got x minus 2. Then I look at my last one. The x minus 2 is already accounted for, so I don't have to worry about that. But what's not accounted for yet?
Yes.
The x. What are my undefined values for this LCD? 2 is an undefined value. What else?
Negative 2?
Nope. Negative 2 is okay. What if I put this x? X cannot be what?
Negative 1? I mean, negative x?
It can't be 0. So do you see how I have this x factored out right here? Do you see this x? This would be x equals 0 or x minus 2 equals 0. If we were solving that quadratic, it would be x equals 0 and x minus 2 equals 0. So in this situation right here, we cannot have a 2 and we cannot have a 0. So if I get either one of those as my answers, then I have to throw it out. Okay, so I am going to multiply everything times my LCD. Okay, so I have x times x minus 2 over 1. So x times x minus 2 over 1 is times 2. Okay, x times x minus 2. And I need to keep that x minus 2 in parentheses. I apologize, I didn't do that on the first one. Okay, and then I am multiplying that times 4 over x minus 2. And then my last rational I've got is x times x minus 2 over 1. Okay? Can I cancel anything in this first one? Is there anything in the denominator of 2 that I can cancel? So I am actually going to be distributing a 2x to that. I've got my 2 here, my x here, and my x minus 2. So I've got to multiply all of those together. Here, my x minus 2 cancels. So I'm left with x and 4. Here, everything cancels, and I'm left with 8. Okay? Now, what's the first thing I have to do here? Distribute. So I have 2x squared minus 4x plus 4x equals 8. What happens to the negative 4x and the 4x? Good. So I still have a quadratic. Okay? I could do this a couple of different ways. If I divide by 2, I'm left with x squared equals 4. If x squared equals 4, what does x equal?
2.
And? Okay. Don't forget that negative 2. It equals 2 and negative 2. That's one way to do it. The other way I could do it is once I got x squared equals 4, I could set that equal to 0 and then factor. If you do it this way, you're not going to forget that negative 2. Okay? If you still set it equal to 0 and solve the difference of perfect squares, you're not going to forget that negative 2. So then this is x plus 2 equals 0, x minus 2 equals 0, x is negative 2, and x is positive 2. But what do we know about x is positive 2?
Can't have that.
Can't have it. So we have to throw this out. So my only answer to this one is x equals negative 2. That is my only answer. I had to throw out the x equals 2 because it made a denominator 0. Okay? Your quiz is due to me by 3 p.m. tomorrow. I am going to be at a funeral tomorrow. So stick it under my door if you have not already turned your quiz in. If you have your quiz, I would encourage you to go ahead and give it to me. But it's due tomorrow by 3 p.m. If you are struggling with the quiz, you can come and see me this afternoon and we will do classwork. The classwork is what's going to help you on the quiz. So make sure you have mastered the classwork. Your test is Monday the 18th. Have a good day.